Can someone please say something? I am not able to hear your voice.
Yes, sir.
Okay. Someone other than. Right. So, okay, I'm going to check the chats. No, I'm not able to hear you. So can please someone please say something? I'm not able to hear your voice. I want to confirm whether that is a problem with my side or something else is wrong. Your voice is not coming to me. Okay, all right. So maybe I'm not able to hear you. Can someone please confirm? I mean, can someone please say something? I want to know whether it's problem from my end or something else.
I'm able to hear you.
Uh, yes, someone has raised. All right, so I don't know whether something is wrong with you. So I'll just keep on speaking. If you have a problem, raise your hands. No, no, I am audible. I know. I want to know whether you are audible to me or not. If you ask something, then I will not be able to listen, right? I know you. I am audible to you, but I just want to confirm whether you are audible to me or not, because I'm not able to hear anything that you are saying. I don't know whether you are saying something or not. That is why I'm trying to confirm. I'm asking you to say something, speak up something, so that I know whether my earphones are working properly or not. All right. If you must, I mean, in the middle of when I'm doing something, I'm writing something. In the middle of that, I may not check messages. Anyway, I will check the messages frequently so that if there is a problem, we'll figure it out. Anyway, so yeah, I'll share my screen. All right. So okay. Before starting anything again, as always. So this course is NPTEL course. Its name is Basic Electrical Circuits, and the instructor for this course is Sir Gajendranath Chaudhary. He is from IIT Hyderabad. He is a faculty member there in the Department of Electrical Engineering. Oh, I am. My name is Mayank Anupam. I am a tutor for this course. My name is Mayank Anupam. and so I am currently enrolled in a PhD program in electrical engineering at IIT Kanpur. All right, so quick recap now. In the today we'll be discussing week 7's content. Okay, so right, week 7, right? Yeah, week 7's content. So what all did we learn in week 7? So quick recap of that. Uh, so what all did we saw in week 7? All right. So what did we see in week 7? We saw about so last week we saw I mean we were just introduced to the notion of two port parameters, right? And we saw what parameters? Y parameter and only Y parameter, right? So this week we saw Z parameters. Okay. So Z, we saw H parameters, we saw G parameters, right? All these three parameters we saw. These three parameters. After that, we also saw reciprocity, right? Reciprocity for I mean we saw reciprocity in general, right? And we saw that in a reciprocal network, what is the what is the relationship between the two port parameters? So it's generally, I mean, in a reciprocal system, the two port parameters are for Z and Y, they are symmetric, right? They are symmetric. The two port parameters Z12 is equal to, for reciprocal network, Z12 is equal to Z21. Similarly, Y12 is equal to Y21, correct? H12 is equal to minus H21, and what? G12 is equal to minus G21, correct? We saw this reciprocal networks. We saw reciprocity holds for resistive networks, right? For a system which has controlled sources in it, reciprocity might not be valid. Okay, I mean it for a resistive, purely resistive network, reciprocity is always valid. Okay, for a network which contains only resistors, it will always be reciprocal. However, if a network has some control sources in it, then we cannot comment directly. We cannot make a general statement after that. A network which contains control sources can be reciprocal, or it cannot. It may not be. It may be also. We cannot say just like that. We have to look at the network. Okay. All right. We saw reciprocity. What else? So these two were the main things. Two main things which were covered in the week, right? We saw a whole lot of things on these. All right. So today we'll be solving some questions based on these concepts. All right. I hope this is visible. Okay. So this is a network. Okay. This is a network that has been given to you. Simple network. We want to find out the Z parameters between port 1 and, I mean, so this is port 1, right? This is port 2. We want to find out the Z parameters here. How will we do it? So let's say it can be represented as a two port network like this. Sorry. So let's say this is a two port network. Okay. This is 1, this is 1 prime, this is 2, this is 2 prime. Okay. And let's say the matrix which describes this network is Z11, Z12, Z21 and Z22. So we want to find out this matrix. Okay, so what should I do for Z parameters? We know that the relationship, so for Z parameters, what is the relationship? It is actually V1 is equal to I1 times Z11 plus I2 times Z22, correct? And V2 is equal to what? I2 times Z12, sorry, Z21, this is actually Z12 plus I2 times Z22, right? The independent variable is I1 and I2. So basically this is this way, right? That we have V1 and V2, these are actually equal to Z11, Z12, Z21, Z22 times I1 and I2. So I1 and I2 are the two independent variables here, and this V1 and V2 are the things that you are going to observe because of the application of these independent sources. Okay, so in order to find out the different Z parameters here, Z11, Z12, Z22 and Z12, Z21, what do we have to do? So this is the network, right? So how do you find Z11? What is Z11? Equal to V1 upon I1 when I2 equal to 0, right? When I2 is equal to 0, then what is the value of V1 by I1? That is called Z11. So how do you do it? You have to apply a current source here, right? You have to find out what is the voltage here, V1. Okay, this is I1. And what do you need to do here? I2 has to be made equal to 0, right? So you have to open circuit these two terminals, right? Connect nothing in between, you just open circuit it so that this current I2 will be in this direction, is equal to 0. Okay, fine. So what will it be? When you open circuit this guy here, what is the overall resistance here?
ZA plus ZAB.
The overall resistance here will be ZA plus
ZA plus
ZAB, right?
ZAB.
What is the V1 by I1? It is simply the total resistance that we see looking into this network, right? Because this network was anyway 0. So the total resistance looking here will be ZA plus ZAB, right? So this is actually Z11, ZA plus ZAB. Now we as well, so now again, what is Z21? What is Z21? This is V2 upon this is V2 upon I1 when I2 is 0, right? Again the same thing, you just have to open circuit this network here. It's just open circuited right now, and you have to find out what is the voltage V2 that is appearing here. Okay, this node voltage V2 you have to find out when the current is applied here. So what will it be? V2 here, because of this current I1. Yes, it will be ZAB divided by
I1
ZA
into
plus ZAB,
ZAB.
right? Sorry, it will not be that. It will be ZAB times V2 equal to
I1.
ZAB times I1, right? That is a voltage V2 that will be appearing here, correct? So again, this is equal to ZAB, right? So we got Z11 and Z21. Now let's find out what is the value of so now let's find out what is the value of Z12. Z12 is equal to what? V1 upon I2 when I1 equal to 0. So it is basically the same thing, but done in opposite manner. So now rather than connecting it here, we connect it here, the same current. Now this is I2, okay, and this is V2, this is V1. Now we are just keeping it as open, okay. So the current I1 is equal to 0. Now tell me, what is Z12? V1 upon I2. So this is V1 upon I2. What will it be? Same thing, right? ZAB. Clearly seen, right? You see this current here, it goes and flows here. The voltage it will generate here will be the same as the voltage it will that will appear here. So what is this voltage? ZAB multiplied by I2. So this is also ZAB. And now what is Z22? It's equal to V2 upon I2 when I1 equal to 0. So it's simply this voltage here, correct? So what will that be? This voltage here, this will be ZB plus ZAB, right? This will be ZB plus ZAB. So this will be ZB plus ZAB. So now we have all the four parameters, right? Z11, Z12, Z21, Z22. So now we can write the matrix here. Our two-port matrix will look something like this. So this is ZA plus ZAB. This is ZAB. This is ZAB, and this is ZB plus ZAB. Correct? This is our Z parameters matrix. Okay. Now you can again see that this is a symmetric matrix, right? You see this entry here and this entry here are equal. So this is a purely a network which contains only impedances, right? No control sources. So that is why this is symmetric. And if it is symmetric, that means it is reciprocal, right? So in general, a network which contains only impedances, okay, and not any control sources, it will always be a reciprocal network, which means that its Z matrix, Y matrix will both be symmetric. Okay.
Sir,
Now
can
in
you
this case, you can
repeat
easily invert it to find out Y parameters also. That's also possible. So that is an exercise which you can do for yourself. Let's move on. By the way, any doubt in the first question?
Sir, can you repeat once again?
I'm not able to hear you properly, so maybe you can message it if you have any doubt. All right. Moving on to the second part, second question. So here we need to find out what are the Y parameters. So you see, I guess something like this was already covered in the lectures also. So in general, you can be given any network. Okay, I mean you do not know. Pardon me. So in general, you might not know what is there in this network. Okay, but if you are told, if you are given the terminal characteristics, so what does Y parameters represent? What does Y parameters represent? It represents the relationship between the terminal this terminal voltages and currents, right, of the network. So as long as you have that, you do not need to worry about what is there inside the network. So if you are given a Y parameter, if you are given the Y parameters of a two-port network, that's good enough to understand everything about the network. If you do not want to go inside that, if you are only concerned about the terminal characteristic of that network, okay, that is the relationship between the terminal voltages and terminal currents, then you only need the Y parameters here. Okay, fine. So now that you are given these Y parameters, can you find out what are the Y parameters of the overall network? So this overall network, it can be presented like this, right? Uh, uh, what do I need to tell once, Abhay? So you asked me something to
Sir, first
to
one.
tell something. So what do you want me to repeat?
Sir, first ones.
First one. The first problem. Do you want me to repeat? Okay, all right. Could you please hold on for a minute? I will quickly get out of the meeting and then I can join. Maybe then I will be able to hear you properly. Okay. I just, now can you speak up, please? Can someone please speak?
Yes, sir.
Can
Sir, are
someone
you
please
able
speak
to
now?
hear?
No luck.
Sir, are you able to hear?
Looks like I'm not. No luck. I'm not able to hear anything from what you're saying. Yeah, Abhay, could you please speak again?
Sir, are you able to hear?
No luck. Not able to hear anything. Anyway, fine. It's okay. We'll talk on the messages only. Yeah. So, yeah, the first question I will again explain. Okay. This is the first question. You see, in the first question, I wanted to find out the Z parameters of this network. Okay. The network is this. Yeah. The network was only this. Okay. The network was only this, and I want to find out the Z parameters of this network. So this network here, okay, it can be represented like this, right? The ports are 1 and 1 prime, 2 and 2 prime, right? Only 2 port network. So I can represent it like this also. Now I want to find out the different the Z parameters means this matrix I want to find out, right? So I want to find out what is Z11, Z12, Z21 and Z22, correct? So what will I do to find it out? So I know the relationship. What is the relationship here for Z parameters? The terminal voltages and terminal currents. I know what is the relationship. It is actually Z11 times I1 plus I2 times Z12. This is voltage V1. Similarly, voltage V2 is like this. Correct? I hope this is known to you. This is clear to you. Fine. Now with this information, now if I want to find out what is Z11, what is this Z11? The Z11 is this, right? V1 upon I1 when I2 equal to 0, isn't it? If I2 is turned to 0 here, then V1 upon I1, that ratio will be Z11, isn't it? So this is what I have written here, Z11 here. So how will I do that? I2 for I2 to become 0, what should I do? I have to open circuit this, right? I have to open circuit this. I cannot connect anything in here. So this is I2, this is I1, correct? And what will I do? I will connect a current source here. This is the this is the voltage V1 and this is voltage V2, correct? So now with this situation here, tell me what will be this current is 0, right? This current is 0. So tell me what is V1 upon I1 here? It is actually ZA plus ZAB, right? So similarly you can find out, so that is why it is ZA plus ZAB here. Similarly you can find out all the other parameters. So is that clear, Abhay? Okay, fine. So I will be proceeding now with the second question. So by the way, I just wanted you to appreciate the fact that in this case, Z parameters here, you see, this is a symmetric matrix, isn't it? You see the off diagonal elements, they are same, correct? And the diagonal across this diagonal, this matrix is symmetric. So in general, if you have a system, if you have a network which contains only the impedances, okay, only impedances. So in that case, if it doesn't contain any control sources, in that case the network will be reciprocal. And what does a reciprocal network's matrix look like? It is symmetric, right? The Z matrix is symmetric. Okay, moving on. Yeah, so second question, I want to find out the y parameters of this network. So yeah, so let's do this. So okay, the whole network here, it can be compressed in this manner. The whole network here between these terminals 1 and 2, what do I need to do? I need to do this. So this is terminal 1, this is terminal 2, 1 prime, and for the second port I have terminal 2 and 2 prime, 2 and 2 prime. Okay, and I want to find out the overall y parameters of this network, right? I want to find out what is y11, y12, y21 and y22. So how will I do that? So this is, I know the y parameters of this network which is inside here, and I know what is this 1 ohm resistor. So I know this too. From this I have to come to the overall network's y parameters. So how will I do that? Okay, so that is, let's look at it. So this is so I know the y parameter of this is what, 5 3 1 2, correct? And okay, this is a resistor here. It's only 1 ohm resistor. Okay, now so let's name so let's call this point as 1 and 1 prime. So this is 1 and 1 prime, right? So let's call this 1x and 1x prime. Let's call this 2x and 2x prime. This is 2 and 2 prime. Okay, so these terminals, let's call okay, so let's call the voltages here as equal to, maybe this is v1 and v1 prime, this is v2 and v2 prime. No, sorry, this voltage let's call it v1 prime, this voltage let's call it v2 prime. The outside of this at this point here, okay, at this point here, this voltage is v1 and this voltage here is what, v2. Let's call it like that. Okay, again this quantity here I1, let's call it let's call it I2 prime, this is I1 prime. Okay, similarly this is v1, let's call this I1. Okay, let's call it I2. Okay, 2x was only a number, okay, just ignore it. It is not 2x, it's not 2 times, it is just a number. So I've removed that. That might simply create confusions, that notation. But this notation clear? So at this point here and this point here, this is where I want to find the overall, this is the overall network, right? For that I want to find out the y parameters, right? So how do I find out the y parameters? I know that I just have to connect two voltage sources, right? What is the y parameter relationship? So it is actually equal to v1 equal to, sorry, I1 equal to v1 times y11 plus v2 times y12. Only I2 equals v1 v1 times y21 plus V2 times Y22. This is the this is what? This is the Y parameter relationship, right? You know that. So this is what I have written here for this network. I have applied a, so in this case the independent voltage is what? The independent voltage source is what? In this independent source is what? V1 and V2, correct? And based on this independent source, what is the value of the current that is entering? These currents are calculated. These currents will be dependent upon the value of the voltage source. These voltage sources are independent variables in this particular formulation, in this particular Y parameter. So this is the independent variable V1 and V2, and I1 and I2 are the dependent variables. Okay, fine. So from here, can we calculate what are the Y parameters of the overall network? So let's look at it. So tell me, what is I1 here? Okay, so what is Y11 here? Let's go one by one. So what is Y11? Y11 is I1 upon V1 when V2 equals 0, right? When V2 equals 0, that is the ratio I1 by V1 is Y11, right? So let's do that. Let's make V2 go to 0. So this guy, when it goes to 0, it means that it is shorted, right? It is simply shorted here. So simply shorted. Okay. Now what is, if it is shorted, what is I1 in that case? This current I1, what is it? What is this current I1? It's actually equal to I1 prime plus this I1 prime, right? Plus whatever current is going here. So what is the current that is going to go here? This node voltage is V1, correct? And please notice that this node voltage V1 is actually equal to V1 prime, isn't it? V1 and V1 prime are same, correct? Because they are the voltage across the same terminals, correct? So I1 prime is what? V1 minus this voltage, right? But this voltage is shorted. So what is this is actually shorted, right? So what is this voltage here? It's actually 0, right? Is that clear? Is that clear? Okay, I mean it is shorted here, so this voltage is 0, right? So V1 minus whatever this voltage I don't know, so this is just 0. V1 by 1, correct? All right, this is Y11. So but I do not know what is I1 prime, right? I do not know what is I1 prime in terms of V1. So let's calculate that also. So I know the internal characteristic of this network, this Y parameter of this network. So for this smaller network, what is the Y parameter relationship here? So in this case, I1 prime is equal to what? 5 times V1 prime plus 3 times V2 prime. So only I2 prime is equal to what? 1 times V1 prime plus 2 times V2 prime. We have this relationship for the smaller network. So from here, can we find out what is this I1 prime in terms of V1? Yes, we can, right? See, in this case, V2 prime is shorted, right? V2 prime is equal to 0, correct? The voltage across these two terminals is actually equal to 0. So that is why I1 prime will actually be equal to 5 times V1 prime, right? So it will actually 5 times V1 prime plus V1. But we know that V1 prime and V1 are the same, right? Here. So this is actually equal to 6 times V1 prime, right? So what do we have here? So we have what? Y11 equal to I1 upon V1 when V2 equal to 0. So what is I1? 6 times V1, okay, divided by V1. So this is equal to 6. 6 what? 6 Siemens. Okay, all right. So this is clear. Now what is y12, or maybe what is y21? Y21 is what? I2 upon V1 when V2 equal to 0. Correct? Isn't it? So what will it be? Again, what is I2? What is I2 here? You see I2 here is what? I2 prime plus whatever is going here. So I2 is equal to I2 prime plus what is going here? Come on, what is going here? And what is going here in this direction is actually equal to minus V1 upon 1, right? The same, this is the current V1 upon 1 ampere, but we have taken it in a positive direction, so that is why I added a minus sign, right? So now this is equal to how much? So now what is I2 prime? What is I2 prime? I cannot calculate it. I have to find I2 prime in terms of V1, right? So what will I2 prime be? Again, coming from here, you see I2 prime is equal to 1 times V1 prime, and V1 prime is nothing but V1. So this is actually equal to 1 times V1 minus 1 times V1. This is actually equal to 0, right? So I2 equal to 0. So what is Y21? It's actually equal to I2 upon V1 when V2 is equal to 0. So but this is actually equal to 0 upon V1. It's equal to 0. Right? So Y21 is 0. Only similarly you can find out what is Y2, what is Y12. So what is Y12? It's actually equal to I1 upon V2 when V1 equal to 0. So you have to apply a voltage at the second terminal, second port. Okay, this is now not shorted, but this is shorted. So now you have to short this guy here, but you have to apply a voltage here. This is V2, right? And you have to find out what is I1. What is the current I1 that is going to enter here, right? What is the current I1 that is going to enter here? So this you can do, right? So what is the current that is going to enter here? I1 is equal to how much? I1 prime again plus V2 minus, or sorry, minus V2 upon, this current is minus V2 upon 1, right? And what is I1 prime? What is I1 prime in this case? When the first node is shorted, first port is shorted, you can find it from here, right? It's actually equal to 3 V2 prime, right? It's actually equal to 3 times V2 prime plus minus V2 upon 1. And what is V2 prime? V2 prime is already equal to V2, right? Because V2 prime is the voltage here, V2 is the voltage here, both are same, right? Same terminal, across the same terminal. Fine, fine. So this is, how much is this? 3 minus 1 is 2, so it is 2V1, sorry, 2V2. So that now your Y12 is equal to V2 upon, sorry, I2 upon I1 upon V2 when V1 equal to 0, which is actually equal to 2 Siemens. Correct? Similarly, you can find out what is Y22, so that you can do it yourself. I'm not going to do that here. Any doubt here? Any doubt in this question? So basically, in this question, you were given this small network, and you connected something here, outside of the network, and now you want to find out what is the overall network's Y parameters. Okay, so for that you do these kind of manipulations, small manipulations, you will get it. All right. So if there is no doubt here, we'll be moving forward now. Okay. Again, this question is okay. See this question here. Now you want to find out what is this voltage V naught due to Vs, and what is the transfer function V naught over Vs. How will you do that in this question? You have been given this Y network here and its Y parameters. Okay. This is some network here. You have been given the Y parameters of this network. You have to find out what is the what is the transfer function between V naught and Vs to V naught. So how will you do that? So can you notice something about this Y parameters? This is something interesting, right? The Y parameters is the off diagonal entries are 0, correct? So what is Y parameter relationship? So it is like I1 is equal to V1 times Y11 plus V2 times Y22 Y2 sorry Y12. Similarly, I2 is equal to V1 times Y21 plus V2 times Y22. So if your off diagonal entries are 0, so this is what? This is Y12, this is Y21, correct? This is Y11, this is Y22. So if your Y12 and Y21 are 0, basically this quantity is 0, this quantity is also 0. In that case, the current and voltage across at the terminals depend only on the, so the current here I1 will depend upon only the voltage at that particular terminal port, and similarly the current Y2 will only depend upon the voltage across that port at that port, right? So it's just like a simple resistor, right? This is the this Y matrix here. It's the Y parameters of a simple resistor, two simple resistors. So it will look something of this kind. So let's say this is port 1, okay. So here is a resistor in this way, and here is another resistor in this way. So this is 2 prime. So this is what? This is 1 over 2 k, okay, and this is 1 over 10k. So how much will this be? 500 ohms, and this will be 100 ohms. Okay, this is how it is. So this network here, it can be understood like this. This is 500 ohms. This is 100 ohms. Okay, or maybe I'll just put it inside here. It's 500 ohms. This is 100 ohms. All right. Now you have to find out what is the voltage here. So how will you do that? Now this is very easy, right? This network here. So this network here, it looks, if I redraw it, it will look something of this kind. So this is your Vs, /60 ohms, and this is 100 ohms. This is and this is the voltage that we are interested in. This is 100 ohms. This is 500 ohms. This is 100 ohms again. Correct? This network we are interested in. So tell me what will be the situation here. Now it is very easy to solve. Simple network, right? So 300 ohm plus 100 ohms. These are in series, so it will become 400 ohms, which will come in parallel with 100 ohms. So what will the equivalent resistance be? So it will be 400 into 100, right? 400 into 100 upon 500. So this is 80 ohms, right? So at this point we will have a 80 ohm resistance in series with another 500, which is 580 plus another series 60. So it will be 580 plus 60, which is 640 ohms. So the current that will be passing here will be how much? Vs upon 640 ohms, right? This is the current I. So Is is equal to 640 ohms. All right. And now we have to find out what we have to find out what is this voltage V naught. So tell me, what will it be? What will this voltage be? Vs upon 640 into how much? 80, right? So it is actually 8. So it is Vs upon 8, this voltage here, Vs upon 8. So what will this voltage be? V naught, another resistive division, right? So V naught will be Vs by 8 into 300 by 400. It shall be 3 by 4 into 8. So it is something like 3 Vs upon 32. Right. So what is V naught upon Vs? It is 3 upon 32. I hope this was clear. I mean, this is just trivial, right? This exercise is trivial. What I wanted you to appreciate was that just by looking at the y matrix, y parameter matrix, I was able to deduct it very easily. I mean, I simply saw the y matrix here, and I saw the off diagonal entries are 0. Okay, and I concluded that okay, so in this case, this should only be two resistors like this. So this made the life very easy, right? This made the whole calculation very easy. So this you should be you should put a very close eye. You should keep a I mean, you should be very observant of these things. You should always keep a close eye on these small intricacies. This will make your life comfortable. Okay. So is there any doubt in this question? All right. Moving on. Okay. Hmm. Yeah. In this circuit shown below, it is not below, it is above. Okay. Okay. So this circuit shown above here. Okay. We know that when the voltage V1 is 100 volts, this voltage when it is 10 volts, the current I is 1 ampere. So this is 1 ampere when this is 10 volts. Okay. So when this is 10 volts, this current I is equal to 1 ampere. If the applied voltage at port 2 is 100 volts, the short circuit current flowing through port 1 will be how much? Can anyone please give me a hint here? So it is given here. It is a linear resistive network. How should I proceed? I know that when I apply voltage of 10 volts here, I get a current of 1 ampere, short circuit current 1 ampere. Now the question is a question that is being asked here is that if let's say I apply a voltage source here, okay, by the way this is not there in that case. I apply a voltage here of 100 volts, then what is the current that is going to flow here? In that case the short circuit, this short circuited, okay? In that case what is the current here? Hmm. Okay, so let me do this. So what is this relationship, by the way? V1, you have applied a voltage at this at the first terminal, at the first port, and you are observing the current leaving the second port. So what is this relationship? So it is actually y parameters, right? So you know y, what is this? I1 equal to y11 times v1 plus y12 times v2. Similarly, I2 is equal to y21 times v1 plus y22 times v2. Okay, in this case, in the first scenario, you have short circuited the second port, right? So v2 goes to 0. Okay, so now you have I1 equal to y11 times v1, and here it is I2 equal to y21 times v1, right? And you are saying this current here is I, this current here is I minus of I2, right? Because I2 we take in this direction, I1 we take in this direction. So this is minus I2, correct? So what is minus I2? Minus I2 is actually equal to minus y21 up into v1 is equal to 1 amperes, right? So what is v2 y21 is 1 ampere upon v1 is equal to 10 volts, correct? So this is your y21. Y21 is 0.1 Siemens. Okay, now it is given that it is a linear resistive network. So if it is a linear resistive network, what did we all learn about it? We saw that if it is a linear resistive network, then it will be a reciprocal network, right? It is a reciprocal network if it is a resistive network. If it is a linear resistor, if only linear resistors are present in this network, then it's a reciprocal network. In that case, the parameters y12 and y21, they will be equal, right? So if you have the y parameters like this, y11, y12, y21 and y22, then basically if it is a reciprocal network, then these two entries will be same, right? So in this case, we have y12 equal to y21 when reciprocal, when the network is reciprocal, correct? So that is why from here, from this relationship, you can directly say that you already know what is y21. So what is y12? Simply equal to y21, which is equal to 0.1 Siemens, correct? And you see, if you see the second part of this question, says that if the applied voltage at port 2 is 100 volts, the short circuit current flowing through port 1 will be how much? So second question actually asks you that only. So basically you want to find out what is I1, what is I1 upon V2, right? When V1 is shorted, that is what you want to find out. You have applied a voltage V2 here, right? Voltage at port 2 is 100 volts. You want to find out what is the current through port 1, so that you want to find out I1 when the short circuit current, so that this V1 voltage is equal to 0. The port 1 is actually short circuited. So this is actually how much? This is actually equal to 0.1 only, correct? Oh, minus 0.1, by the way. This is minus 0.1 Siemens. Okay. So tell me what is I1 in that case. I1 is equal to minus 0.1 Siemens into V2 when V1 equal to 0. And what is V2? V2 equal to 100 volts, right? So this is actually equal to minus 10 amperes, right? So if it is a minus sign in the current, that means the current direction is not this one, but but the reverse, right? The current is 10 ampere, which is going to flow in this direction, correct? So this is actually a question which is illustrating the use of reciprocity. I hope it is understood by all of you. Fine, so I will move forward. I will moving forward now. Hmm. So I said that in general, if a network contains only resistors, only linear resistors, then the network is reciprocal. However, if the network contains certain this thing, certain some control sources, you will not be able to comment about its reciprocity straight away. You can make it reciprocal. You can also make it not non-reciprocal. That depends. Okay, that depends upon the network. You cannot just make a general statement after that. So in this condition, in this case also, we have two control sources, right? And even with these control sources present, the circuit can be made reciprocal, right? I mean, this is what we know. In the presence of in the presence of control sources also, we can make the circuit reciprocal. Now we want to find out how we can make the circuit reciprocal. So in this case also, if we choose this parameter a here, then for certain values of a, this network here, it might become a reciprocal network. We want to find out what are those what will be the value of that a. So we can choose actually any value, any parameters for these. I mean, we can also go with y parameters, we can go for z parameters. All these are okay, both of these are okay, because if a network is reciprocal, then the y parameter matrix and z parameter matrix both are symmetric. So for doing this analysis here, I will simply choose one of these. So tell me, what should I choose here? I'll be choosing z parameters. Okay, I'll be choosing z parameters. So let's choose z parameters. Let's choose z parameters. All right. So tell me, what is z11? Is actually equal to v1 upon i1 when i2 equals to 0. So tell me, what will it be? So this is already open circuited, no problem, right? So the current here is anyway 0. So what is v1 upon i1? Yeah, come on. What is v1 upon i1? So it's actually equal to how much? Mm, what is v1 upon i1? So if you connect a current source here, then the current entering here is i1. The voltage drop across this is I1 into 3 plus AI1. Just write KVL, right? So we have V1 equal to, so this is I1 and V1. So V1 equals to how much? 0.5 V1 plus I1 3 times I1 plus 8 times I1. Correct? This is V1. So from here I know that actually equal to V1 by 2 equal to 3 plus A times I1. So V1 upon I1 is equal to 2 into 3 plus A. So this is equal to 2 into 3 plus A. So this is Z11. Okay. So I have simply written KVL here in this loop. I have written KVL here. Okay. Fine. So I found out what is the Z11. Now tell me, what is Z21? What is Z21? Z21 is V2 upon I1 when I2 equal to 0. So what is V2? V2 is this voltage, right? Voltage across this. So what is this? Actually equal to
2i1 plus ai1
2 into I1 plus A into I1,
ai1.
right? This is
Okay.
2 plus A times I1. So okay. So V2 equal to 2 plus A times I1. That means V2 upon I1 is how much? 2 plus A. So it's actually equal to 2 plus A, right? Similarly, tell me what is Z12. Z12 is V1 upon I2 when I1 equal to
I1 is
0,
0.
right? So now
Yes.
you have open circuited this here, but you have connected something here. You have now connected a current source here like this, I2. You want to find out what is V1. What is V1 here because of this current? So tell me what will it be? First of all, the current here I2 will only pass through this, right? And nowhere else. This current
Okay,
is
sir.
0, right? So this voltage also 0. So how much is the voltage drop V2? V2 equal to 2
0.
times.
2 times I2, sir.
Okay, so I will just write it. You can solve it on your own also. So let's. I will be solving it. You see if you see any discrepancy, please tell me. So here we have how much? Here we can solve. If you see this is I2, this is V2. So if you see this is V2 equal to how much? V2 equals I1 times 2. This is 2I1. Okay, because A
Okay.
times I1 will be 0 because I1 is 0. Okay, so there is no voltage drop in this, so that is why it is 2I1. V2 is 2I1. Now I will now be using KVL in this section here. Okay, so V1, this is the voltage from here to here, voltage gain, right? So this is the voltage between here to here is equal to how much? It's equal to voltage in here, right? So what will that be?
Okay.
So V1 equal to, or
Sir,
maybe
it
I'll
will be
just go
V2.
around this loop. V1 minus 0.5 V1, okay, plus minus V2 equals 0. So actually V1 by 2 equals V2. So that V1 equal to 2V2 here.
2V2.
Okay. And what is V2? V2 is equal to 2I1. So it is actually equal to 4I1 here. 4I2 here. Sorry. It's I2. So that what do we will have? V1 upon I2
Z.
is equal to 4.
4.
Is equal to 4. Is this point clear?
Yes, sir.
Z12 is 4. Correct?
Okay, sir.
Z12 is 4. Now, for a reciprocal network, we wanted to find out what should be the value of A such that the overall network is reciprocal. For a reciprocal network, we know that Z12 has to be equal to Z21. Correct? So what is
Okay.
Z21 here? 2 plus A. What is Z12? A. So what is Z12 is? Z12 is 4, and it should be equal to 2 plus A. From here, A should be equal to 2, right?
Yes, sir.
Correct?
Yes, sir.
Yeah, fine. So, any doubt in this? You see, in general, a network which contains control sources, it might not be reciprocal. Okay, it can be, it cannot be, it may not be reciprocal. So if you want to if you want to understand whether it is reciprocal or not, you have to check the network. So here we were specifically told to make this network reciprocal by changing some things. So in general, if a network contains control sources, it can be made reciprocal by doing some tweaking here and there. That is what is done here. I hope this is clear to you.
Yes, sir.
All right. Okay. Here you want to find out what is the Z in here. You want to find out what is Z in the impedance which is looking this side. What is the impedance looking this side? What is Z in? Okay. So how
Okay,
do you
sir.
find Z in general? So by the way, so
We,
when you look at when you want to find out Z in here, what do you do?
sir,
Looking this side, you want to
oh,
find out, right? So you do not care what is this, what is here. Okay, you do not actually care what is going to be present here. You only want to check what is the. You apply a test current source here. Okay, so for Z in, what do you do is, in this case, you have to first consider only. You have to remove these two here. Okay, you have to consider only this network here. You have to apply a current source here. Let's say this is I in. Okay, and you have to find out the voltage V in here. This is port 1, this is port 1 prime, and this is like this only. You know the Y parameters of this network: 4 minus 0.1, 50, and 1. Okay, you apply a voltage current source here, and then you want to find, then Zn is equal to what? It's actually equal to V in upon I in. This is what Zn is. So how will you find it out? So clearly logic says that in this case y parameters are given, but you want to find out ultimately the z in value. So if no one knows nothing, so if no one knows anything, logically the first thing that I should do is I should convert this y parameter matrix into
Z
z
parameter
parameter
matrix.
matrix, right? Because ultimately I want to find out something, some kind of impedance only. Zn is what? Some kind of impedance. I want to give some current source. I want to find out what is the voltage that is going to generate. So let's do that. What is the relation between y parameter and z parameters matrix? Z is equal to y
Y
inverse, right?
inverse.
It's inverse of this. This exists when the system is, I mean, clearly here it is invertible, right? Because you see that that its determinant is not equal to 0. So clearly in this case the inverse exists. So when the inverse exists, then z parameter is always equal to inverse of y parameters. This is always the case. So in this case, what is the inverse of y? Tell me. So it is actually more determinant of y, right?
Yes, sir.
Into
Cofactors of Y matrix.
adjoint matrix, right? That you will get. So what will be the adjoint matrix? 1, 4,
1
0.1 and minus
minus
50,
50.
correct?
Yes, sir.
And what is determinant of y? 4 plus 5, right?
Yes, sir.
It's 9. Alright. By
Okay,
the way,
sir.
this is milli, right? This is milli. So yeah, it is milli. So it is 9, correct? And everywhere instead of milli we will have 1k, 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 and everywhere we will have kilo instead of milli now. So this is this. So we have ultimately the Z matrix is uh, 1 over 9 multiplied by all the entries of the matrix, which is 1k, or maybe I will bring the k outside. There is 1000 over 9 multiplied by 1, 0 0.1, 50 and 4,
4.
minus 50 and 4. This is
Okay,
the
sir.
Z parameter matrix.
Okay, sir.
Okay. Now with this information, let me redraw the circuit that I have. So I have, this is I in. I know the Z parameter matrix here. I have this, so 1 kilo thing here. This is I, this is I2, This is I1. This is a port. This is V1. This is V2. This is I in. Okay, and V1 is actually equal to V in here. This is V in, which is actually equal to V1 here. The Z parameters matrix I know is actually equal to 1, 0.1, minus 50, and 4 is actually equal to 1 upon 9, 1k upon 9, 0.1k upon 9, minus 50k upon 9, 4k upon 9. Yes. Now can we do it? Now it is easy, right? Now it is very easy. So I know the terminal relationship between I1, I2 and V1 and V2. What is that? I know that from the Z parameter matrix I know V1 equal to what? V1 should be equal to I1
Mm.
times Z11
Good.
plus I2 times Z22.
Z-
Z12.
2 1.
Similarly
Acha,
V2 equal
1.
to what? I1 times Z21 plus I2 times Z22. Correct?
Yes,
Now
sir.
already I know that V2 equal to, from this resistor relationship I know that V2 equal to how much? Minus of, so from this V2 equals to minus of 1k into I2, right? So I'll put
Okay,
that
sir.
here, right? I'll put this information here. So V2 equals to minus 1k into I2. This is equal to I1 times Z21 plus I2 times Z22. Correct?
Yes,
And
sir.
what will this be? So from here, I will take I2. I'll find out I2 in terms of I1. Okay. So I2 equals to what? I2 equals to I1 into Z21 divided by Z22 minus Z22 minus plus 1k. This is what I2 is in terms of I1. Now I'll put this back here. So what is V1? V1 is actually equal to V in, right? And what is I1? I1 is actually equal to I in. So I1 is actually equal to I in times Z11 plus I2 is equal to what? Minus I1. I1 is equal to I in times Z21 divided by Z22 plus 1k into Z12. This is what I have from here. Now let's do this. So what is V in upon I in this case? It is Z11 plus, or minus rather, minus Z21 Z12 divided by Z22 plus 1k. So this is the impedance Z in. Okay, and Z11, Z21, Z12 and Z22 you already know from here, so that's not a problem. You can put this back here and then you can calculate it easily. So is that understood? Is that clear what I did here?
Sir, that
If you have
I2
any
is equal
doubt,
to
you can
minus
put
I1
it in
dot
the comment section. So
Z21.
I cannot hear you because I cannot hear you, so you can put it in the comment section.
Hello? Hello?
Anyway, if you have don't, no need to worry, because I will anyway be posting these on the YouTube, so you can go back and refer it again. All right, number 7. So in this question, what do we have? Okay, so we need to find out what is V1 and V2. How do we do that? Again, the same thing. Okay, this network has a y-parameter relationship, but mm, in this case, will be if we convert it into z parameters, it will be much more easier. Okay, so maybe this you can try it yourself, because this and the last questions are almost the same. So this you should try yourself. You convert it into z parameters and then write the same relationship that we wrote. You will be able to find it out. It is easy actually. Alright, so let's move on. Yeah, in this case you have some y parameters here. Okay, you have got a two port y parameters. Now you know the y parameters. You want to find it what is v2 by v1. Okay, so how will you do that? Here you do not need to change it into into z parameters. You can play with y parameters only. That is actually more beneficial. So let's try this actually. Sorry. So let's say this is 1 prime, this is I1, and this is I2, 2 and 2 prime, and here we have a ZL, and this is plus V2 plus V1. Okay, we know the y parameters here. So this is y11, y12, y21, y22. So what is the relationship? I1 is equal to y11 times V1 plus y12 times V2. What is I2? I2 is y21 times V1 plus y22 times V2. These are the this is the relationship that we know. But now using this terminal characteristic of ZL, we can clearly see that there is a direct relationship here. Directly we can find out. So what is Z2? What is V2? It is equal to minus of I2 times ZL, right? So from here, uh, I will eliminate I2, right? I2 is equal to minus V2 upon ZL. Now let's put it here. So what will I get? So when I put this here, so what will I get? I'll actually get minus V2 upon ZL is equal to, or maybe I'll just write it again. Okay. Just from here I get I2 is equal to minus V2 upon ZL should be equal to Y21 into V1 plus Y22 into V2, and maybe I can just replace point one in terms of another. Okay, so what is this? What is this? This is V2 goes in the left hand side, so this is V2 common minus 1 over ZL plus Y22, okay, is equal to Y21 into V1. Okay, so V2 upon V1 is equal to how much? Minus of Y21 divided by Y22 plus 1 over ZL. So we got Y2 V2 upon V1. You see, I mean all these things, all with this, with all these questions, I just want to motivate how to solve problems when you are given two-port network parameters. So for solving any network, if this two-port network is given to you, all you need to know is its y, h, z or g parameters, whatever. So you can say anything about the network. You can do all kinds of calculation on the network on the based on the terminal characteristic of the network. All right. Yeah, it's again the same kind of question, so you can do it. So let's go to the last question. And oh, that's not good. Sorry, I think it didn't refresh properly. Okay. Sorry, I think it didn't refresh properly. Oh yeah, now it refreshed. Okay, so I hope this is visible. It is not. Okay, so basically in this question we are told, we are given that, uh, you see in the first this network here is the same. Okay, both at both places. This network is the same. So what is given is, in the first case you have applied a voltage source, 5-volt voltage source at the first port, and observe what is the current that is leaving the port. It's actually equal to 2 milliamperes here. Okay. Now in the second case you have applied a 6 milliampere current source to the first network, short circuit current source to the first network, sorry, to the first port, and you are trying to find out what is the voltage here. So how will you do that? Yeah, so you see that the two port network is reciprocal, right? The two port network is reciprocal. So what is this, by the way? When you apply a 5 volts voltage source and you find out the short circuit current at the other port, so what is this? So it is actually this condition here. You apply a, so what is y parameters, by the way? You apply some voltage somewhere and you calculate what is the short circuit current at the other port, or at the various ports. So in this case, this 2 milliampere by 5 volt, 2 milliampere by 5 volts, this is case 1. It's actually equal to y, what your application input is at the first port and the output is at second port, so it is y21, right? It's y21. So this is y21. Y21 is equal to 2 milli by 5 volts. So it is actually equal to how much? 0.4 milli Siemens, right? And this will actually be equal to how much? This is, since this is a two-port reciprocal network, this will be equal to y12, right? And what is y12? What is y12? Y12 is basically what? it is what this is y12 is when you apply a voltage at the this thing. When you apply a voltage here of some voltage v in, and you find out what is the short circuit current here, right? Oh, by the way, this 2 milliampere current is moving out of the port, so it is minus 2 milliampere, so it's really minus 0.4 here. Okay, it's minus 0.4 millisecond here. Okay, now in this case, what do we have? We have a current source which is pushing current here, right? The current source is given, and you want to find out what is the open circuit voltage. So what is this? V0 upon 6 milliamperes will be equal to what? This is actually Z parameters, right? So which Z parameter am I talking about here? Input is at the first port, output is at second port. This is actually equal to Z, again 2 1, right? So what will it be? Yeah, Arvind. So is this the doubt? Minus, why is the minus sign here? Is this a doubt for you? Arvind, so I cannot hear you. Could you please like write on the yeah, actually yeah, so this is a negative sign here. All right, so I took into account that. Anyway, so yeah, so I was saying something. Yeah, so basically you want to find out because you have given a voltage source here, okay, and you know what is the current here. So now tell me what is, I mean, if because of this current source, what is going to be the voltage at the second port? So how will you find it out actually? Any idea? So maybe you should think about it. All of you should think about it. This is a good question. So I'll definitely ask you this one the next time. It's actually a good question. So there's a catch here. So I want you to look at it first. Okay. Anyway, the time is also 5:35. Okay. Maybe you should. So definitely look at this question, and I will talk about it next time. Definitely. I want you to first try it out once. Okay. Hmm. All right. So maybe we'll just end the session today at this, and we'll meet again in the next session on Saturday. Okay. Oh, okay. Thanks for joining. Thank you very much.